Hello friends, I'm back with my YouTube channel with a new question. So today's question is H index 2. So the question is given an array of citations sorted in ascending order. Each citation is a non-negative integer of a researcher. Given a function to compute, write a function to compute H index. So we have to compute H index. So what is the definition of H index? A scientist has index H if H of his or her n papers have at least H citations each, and the other n minus H papers have no more than H citation. That means n minus H papers are less than H citations. Okay, so we have to note this point. So first we have to note this point, that is array is sorted. Then the index is H index is exactly n minus H papers have exactly no more than H citations each. So the answer is n minus the index. It is the answer. Like in this example, citations is equal to 0, 1, 3, 5, 6. So 0, 1, 3 means this array means researcher has 5 papers in total and each of them had received 0, 1, 3, 5, 6 citations respectively. Since researcher has 3 papers with at least 3 citations, so there are 3 papers, that is 6, 5 and 3 with at least 3 citations each, and the remaining 2 are no more than 3 citations each. So her H index is 3. So this is the question. So we can do this by linear search in O of n time. Like we iterate through zeroth index to the end of array, and every time we check a condition. If citations of I is greater than equal to citations dot size, the array size minus the index, the ith index. If this condition applies, then we simply return the first value of is this. So let's see what O of n time O of n answer looks like in code. So first we have to check our base conditions. Then we are iterating over the whole array. Sorry. Citations of I. As I said, citations of I is great. If citations of I is greater than equal to citations, the array size, that is citations dot size minus current index, then guess what? We find our answer. So we simply return the answer, that is this. So in this way we can solve this problem in O of n complexity. So accepted. So but here in O of n complexity we are not not applying our property, that is the array is sorted in ascending order. So whenever we see that array is sorted in ascending order, and we can then we can think that we can do this by the help of binary search, because in binary search we have as we have sorted array. So by the help of binary search we can implement this problem. So let's see the binary search approach. So first we need to check our base condition. There is this. So we have to assign two variables, one at the starting of the array and another at the last point of the array. And another for the answer, that is currently 0. So we now have to search through the array. So first we have to find the middle element. So this method to solve a problem, that is this. This is basically, this line is basically preventing our overflow condition, like for very large number where low plus high can be overflow in integer type. So we can prevent this by the help of low plus high minus low. We can reduce it and all. So if we find an index where c of mid like citations of mid is greater than equal to c citations dot size minus mid, then we just have to shrink our we find a middle element, that can be our answer. So we have to shrink to the left side. So now we have to write that answer is this. And we have to shrink our right to the left. If we don't find our citations, that is h index, then we just have to increment our low variable to mid plus 1. This is basically a binary search. Now we just have to return our answer. Yes. So this is the whole process of solving this type of problem. First we can solve it in O of n complexity, then we can reduce it by the help of some properties given in the question, like if array is sorted or not, then how can we find the h index and all. In this way we can solve the any problem. Thank you. Hope you like this video. Like and subscribe. Thank you.